Hey, Math 20-2. So we're going to be getting into lesson, well, it says 2, probably on maybe on your sheet too, but lesson 7. I'm renumbering these so they're all in order now instead of starting over every time. Anyway, lesson 7, properties of quadratic equations. So what this one's going to be about is kind of applying these quadratic equations, which make that shape of a parabola, right, to like an everyday situation, right? So the good news is, for the most part, in the questions, you'll be given the equation, and then we just need to like map that onto reality. Like, how does that make sense with what's actually happening, right? So, for example, this one says the equation of an object in flight is given by, and this says h of t is equal to negative 5t squared plus 20t plus 1. Now, h of t, that really is just y, right? It's just written in function notation, so that if I could put like a number in there, right? I could call that h of 2. And then what that would do would mean that I would replace all of my t's with 2, right? So that's why it's written that way. It's just so that we can throw a number in nice and easy, okay? So don't be afraid of that. And then where h is the height of the object in meters and t is the time in seconds, okay? All right, so now it says determine the maximum height. So you know what? Let's go ahead. Let's actually graph this. And that's what we're going to be doing here. We're going to be just using our graphing calculator to graph this and then kind of make sense of it from there. So grab your graphing calculator. All right, so I got mine. So let's type this in. So where we're going to go, we're going to go to y is equal to, all right? That's where we type our equations in. And it says y1, but that's the same thing as h of t, right? So now we're just going to start from here. So this would be negative 5. And then I can't type t into here, but I can type x. So I'm going to type x squared. So squared down there. Plus 20 x plus 1. Okay, let's see what we got. So now that we have that in there, then we go over here to graph, right? So then we're gonna graph this thing and see what we got. It's a little wheel spinning there showing me that I got something going on. Okay, so pretty good. That looks like a parabola, right? You can tell it goes up and then comes back down again. Sometimes you might not be able to see it that clearly. What we should do though right now, because it's asking me what's the maximum, that's the first one we're looking for. I can't see the maximum, right? So what I got to do is I got to see a little bit higher. So that means I got to go into my window settings, right? I want to change what I'm looking at. So right now, it looked like the X min and the X max were okay. Here, you know what? I might be able to change that too. You know what? I only want to see this, right? So I don't need to see way over here. So let's change that too. Let's change our X min to, instead of negative 5, let's change it to, or negative 10. Let's make it like negative 2. And our X max is a little bigger than it need to be too. Let's get a good picture here. This would be, I don't know, like even 8 would make it a little bit nicer. I won't mess around with the scale, right? Just scale means it goes up by 1 every time for the X. And then the Y min, yeah, you know, that doesn't need to be that low either. Let's make that like negative 4. And then the max, that was the one, the Y max, up and down, right? That's the one I need to change. So it's 10 right now. Why don't we make it like, 30, just to make sure we can see it for now. So graph. And then there you go. 30 was a good idea, right? 20 would have been right at the top there. So yeah, perfect. That's a good view of what I got going on here. So now, like it said, what is the max, right? Determine the maximum height. So the thing about this unit is we want to remember what our axes are, right? So this is my height. If I was graphing this thing, this would be my h value up and down. And this would be time going across the bottom. Okay, so you know what? Let's actually sketch this in quick just so that you have it in your notes and we can refer back to it. So our graph, we have that going on, goes up and then back down again, right? That's pretty much what we're looking at. And we just want to remember that up and down, right? This is our height, which makes sense, right? That's what this is, like our y value, up and down. It's our y axis. And then this is time ticking across the bottom. So these are like my seconds, right? All right, I'll leave it like that for now, though, but that'll give us a good idea. So now if we want to figure out what the maximum height was, you've probably already guessed it, right? The maximum height is right there, right at the peak. Okay, so what we have to do is we got to find our maximum. So let's do that. So we'll go to our calculator. And to find the maximum, all of your stuff is under calculate. So right there. So we're going to go second and then calc, and then you'll get these values. And then in this case, if it was a minimum, we'd choose minimum, but it's definitely at a max. So we're going to do max, right? So go down to 4 or just hit 4. And now what we want to do is it's saying left bound, right? Left bound. So we want to click to the left of where we think it is. So I'll push enter. And then it says right bound question mark. So then I'll click to the right, enter. Now it's saying take a guess. And I say yes, take a guess. Okay, so right there, it says the maximum would be when x is equal to 2.00000001 and y is equal to 21. Now, one little hint here. In this case, when I got 0.000001, that really is like 2 a lot of times. Like sometimes in this calculator, it's like really, really close, and it has to do with the way that computers make calculations. But that, for all extents and purposes, that is 2, right? It's very close to 2, so you just call that 2. Anyway, y is 21, so that would be our maximum height, wouldn't it? And it was measured in meters, so our maximum height, or you know what? Let's figure out what that vertex was. So that vertex was 2, 21, right? That's what we just found there. So the maximum height is 21 meters, right? The y value of that vertex. All right. What is the height at 4 seconds? Okay, so now, height at 4 seconds. Well, 4 seconds, right? That's my time. Okay, that's my time. So that's the one that's going across the bottom. So what we want to know is when we actually get to, 4 seconds right there, what would my height be? Right? That's the question right there. So really what I want to do is I want to figure out at that point right here what that point would be, right? Because this would be like 4 comma something. That'd be like my y value right there. I want to know what that is, right? Because that would be how high it is at 4 seconds. Okay, so again, your calculator is good at this. So let's bring it up again. So calculator. Now again, all of our stuff is under calculate, right? So let's try that. Go second, calc. And then the very first one says value, right? So we'll be able to figure out what the value is. So 1. Now it's saying x is equal to, and this is where I can put it in, right? So x, remember, the calculator says x, but we mean t, right? This is really our time. So we're going to say time at 4 seconds, right? So I'm going to say 4, and then enter. And then it tells me right there, when x is 4, y is 1, right? So it's just off the ground. My ticks were off here, right? This should have been like over here. But so that point right there, the height would be, let's maybe make it there. So if that was 4, it'd be like right there at that point. So that would be the point 4 comma 1, right? So it'd be that. So the height would be 1 meter. All right, moving on. What is the start height? Okay, so looking at our little sketch, the graph here, where do you guys think the start height would be, right? Like, what am I looking for on this graph if I'm trying to figure out how high, right? How high it is at the beginning, right? Well, okay, let's think about this. So at the beginning, the time would be 0, right? So the time would be 0 right here. Okay, so that's really looking for my y-axis, isn't it, right? And that makes sense. That's the height. That's how high you are right at the beginning. So that's what we're looking for. We're looking for our y-intercept. Okay. Now this one, you actually shouldn't even need a calculator for this one. It's actually pretty straightforward. And the reason why it's straightforward, let's think about functions for a second here. If this is my function, right, and I want to know what the value is, what I get out when I put 0 in for t, right, because that's what we really want, 0 in for t, then I could do this. I could say h of t, or h of, what I'm going to do? I'm going to throw in 0, right? That's what we do with function notation. So h of 0 is equal to, and then I'm going to put a 0 in everywhere else here. Negative 5 times 0 squared plus 20 times 0 plus 1, right? You've probably seen what's happening here. Those zeros would cancel. There's like 0 times anything is 0. All we're left with is a 1, okay? So that makes sense, doesn't it? It's always really just the number hanging off the end. That's going to be our y-intercept. So I know without even graphing this thing, our start height, so height is 1 meter, right? Which really just would be this. Now, if you really wanted to, we could have done the same thing, right, as we just did. We could have went calculate value and then put in 0 for x. That would have done the same thing, right? And we would have got 1. Okay, next one. The time spent in the air. All right, so what are we looking for here? Well, the time spent in the air, we can picture this, right? It started at time 0, right? That's where it started, was like right there. And this part of the graph down here, you can imagine that this doesn't actually exist, right? So even though I drew it like we actually see it in the calculator, it doesn't actually exist down there at all, does it? It starts right up here at that height. So it starts at 0, and then it hits the ground right here, right? That's where it crosses the x-axis. So that's really what we're looking for, right? This would be like 4 point something is what I'm expecting, right? Because if that's 4, then it'd be 5 seconds after. This would be 4 point something seconds. Okay, so, and what we're after is the x-intercept. So let's find the x-intercept. Okay, so again, we're going to go into our calculate. So we'll go second, calculate. And then x-intercepts, they're called zeros because the y value is 0. So it's another name. There's a bunch of names for x-intercepts. So, but anyway, on this calculator, they're called zeros. So we'll go 0, enter. And now there's actually 2, right? So I need to get over to the other one, right? I'm looking for the far 0 here. So I'm just going to keep pushing over. And again, it's saying left bound, right? So I don't want to, I want to stop right there, right, where I think it's going to cross. And then right bound, so then I'll move to the right of it, where I think it is. And then take a guess. Yes, I do want to take a guess. So 4.049, right? And that makes sense. We thought it'd be just after 4. Okay, so 4. We can put that on there too. Well, we're kind of running out of room there. 4.049, comma, and then what would that be? What would the y value be? That'd be 0, wouldn't it? That's 0 at that point for y. Okay, and then yeah, so let's go down. So time spent in there. Well, it would be the x value here, right? So the time spent in there would be 4.0 and then 5 maybe. It's just after 4, right? I rounded that 4.9 up to a 5 seconds. And that's it. So that's the idea. Oh, sorry. And then when is it at a height of 2 meters? Okay, so this requires a little bit more. I'm going to make a quick sketch again. Okay, so there's my height. There's my time. Our graph went up and then went back down again. So this saying, when is it at a height? Let's say this. Let's say that we knew that 2 meters was like right here. 2 meters. Okay. Well, can you see that when I do this, there's actually going to be 2 places that this happens, right? There's going to be this spot, right, where it's at 2 meters, and I want to know what time that happens at. And then there's also going to be like over here, where it's at 2 meters. And then I want to know what time that happens at. So there and there. So I'm actually expecting 2 solutions here. And now there's not a great way to just punch the number in like we did last time to figure out what we get out there. But this is going to be typically the method. This will be the best way to do this. So what we're going to do, so again, I want to figure out like where it's at 2 meters. And the reason why this is different is because now they're giving me the y value and I want to figure out what the x value is. So it's kind of the opposite of before. What I'm going to do is I'm going to actually make another line. So let's go down to y2, and I'm going to make just a horizontal line at 2, right? That would give you a horizontal line at 2 meters. And let's see what that looks like. Okay. So now, yeah, that's not very high, right? That's just kind of on the ground there. So my picture was off. But now that helps us because now you can see we got the red line crossing the blue line. And if you zoomed in, you'd see there's a bit of a gap there between the x-axis, right? But either way, now what I'm going to look for is where they cross, right? Because that should be my point of interest there. So let's go second, calculate. Now we have another one, right? We have intersect. So let's go down to that one. Let's go down to intersect. So enter. Now this is very similar to before, right? So here, you know what? I'll find the one to the right first. Doesn't matter which one you do. But anyway, it's the same thing, but this time it's saying first curve. It just wants to know, like, the curve is like the blue line, right? It just wants to know, okay, are you talking about the blue line? And I say yes. So for the most part, though, just try to get this cursor just close to where you want to do it. It doesn't matter if you're right on it or close to it. Anyway, so I'll push enter. And that says, is the red one the second curve? And I say yes. And that says, take a guess. I say yes. And then it says the intersection is at when x is equal to 3.9, y is equal to 2. Okay? So on our graph there, this is really not the scale. Our graph went a lot higher, but it'll work for our purposes here. This is saying that it was 3.9, comma 2. Now the 2 makes sense, doesn't it? Because yeah, we knew that was going to be 2. We drew this line at 2. The y value was always going to be 2. But this is what's interesting. That's our time, right? That's one of our times. So it's at a height of 2 meters at a time of 3.9 seconds. Now we just need to find this one. So we'll just do the same thing. And whoop. Oh no, sorry, I gotta go calculate again. So now I'll go second, calculate, and then intersection again. So 5. And now I gotta keep pushing over until it gets closer. Okay, and then just push enter a bunch of times, right? It's like first curve, enter, second curve, enter, guess, enter, and then there you go. Intersection. And it says 0, it's hard to see, you probably can't see in the video, but it's 0.05 and then 2. 0.05 seconds and then at a height of 2. So when is it at a height of 2 meters? It'll be at 0.05 seconds and 3.9 seconds. And that's it. Okay, so now this question is actually the same as the one above. So you know what I'm going to do? Well, actually, too, we're not going to do these questions as well, if you guys have these on your notes. I'm actually going to go to some of your homework questions, and we can kind of look at those. So one second. Okay, so just kind of, yeah, going through your questions a little bit here. What I want to do on this one, I think you guys will be okay, because like actually the questions are like the same as the ones we were just doing, so I won't even really get into that. The one that might throw you off here, though, is just your window, because you can see the numbers are a little bit bigger. Let's type this one in. I want to show you what will happen. So here, one second. Just bring this up, and I'm going to pause it just so I got a second. Okay, so yeah, looking at this right now, we could just, start typing that in. But just remember our Windows setting is a little funny. I changed everything, right? That'll stay funny. So let's just do it for now, though. So I'll clear these out. So just go to, Y2 and go clear. And then to the top one and go clear. And then let's type it in. So it was negative 4.9 x squared plus 241x plus 400. Okay, and then we'll graph this and see what we got. So graph, and yeah, that doesn't look right, does it? It's still thinking, so I'll give it a second here. But yeah, that's kind of it. So we got like a line going straight up in the air, right? Now, what we can start over, right? Like right now, if you want to start over, a good way to do that is to go zoom and then standard. That kind of gets you back to the beginning. But it's probably not going to be that helpful to us anyway, because it's still going to be a lot higher than what we think. So a couple suggestions here to figure out how high we need to go. One is that, do you see this number here, this plus 400? Well, that means I know that this thing crosses the y-axis way up here, right, at 400. So I need to make my y maximum at least to 400, but probably more because it's going to cross 400 and then probably keep going up and then come back down again, right? So the signal need to be quite large. And we can do it a few times to kind of get our bearings here. The other thing I can see is that I'm not seeing where this thing comes down, so I need to go to the right some too. But for the most part, I think if we go window and then change our y maximum to, and I don't want to make it 400, I want to make it like 800, but probably more. But let's do that for now just to see what we get. So go graph. And then it goes up. Oh, and it's going up a long way, right? It's like a straight line still, right? Okay, so yeah, looking at this, since it's so straight and it's going up so much, right? I think this thing is going to go way, way higher. So I'm not even in the right kind of range here yet, right? So it's going to keep going up. So, you know, let's do a lot. Let's make sure that we can see this thing. So you can make this like 2,000. I'm even going to make it like 3 or 4,000, right? Just because I know I got a long way to go still. So let's graph that. And then, yeah, it's starting to come down, right? Like I think I might end like up here or something is what it's kind of looking like, right? And I can also get a view of this, how far to the right I need to go. Because right now I'm at like 10. This thing seems like the peak's going to be like over here. So I'm going to make my X max like 40 or 50. Let's do that too. So let's go on my X max. Let's make that like 50. And then graph. All right, fingers crossed. Goes up. Oh, we still weren't quite high enough, were we? But we did get the right idea there. Okay, so we're close. So then the X max, I'm actually going to make that 60. Just so I can see the bottom. And then our Y max just had to be, well, 4,000. Why not? And this should work. And again, I just kind of ignored my scale too, right? There's lots of ticks. I don't really care. But there. Perfect. Now I can see everything exactly the way I should, right? If you need to get your x-intercepts, you might want to make your y minimum, right? So our y minimum is only at negative 10. Comparing that to 4,000 is a lot, right? So if you wanted to, we can make that like negative 1,000, just so we can actually see that a little bit better. And then you could actually find the x-intercepts if you needed to, right? Anyway, so that's the idea there. I know that can be a little bit of like work just trying to see it, but that's kind of the process I'd go through. Okay, and now last one I'm going to show you is just something to do with my open math here. So when you get to these questions, there's like 3 of them, and then it'll say graph the equation. So the way this works, you can see on the little picture here that it's 2 dots, right? So the way this works is you click the vertex, like the peak, right, the max or whatever, and then you have to pick some other point on the graph. So what I would do then, if I was graphing this, right, I would put this in my calculator. I would figure out where the maximum was, right? So you could do that. You could figure out where the maximum was, and then make a point, and then you could do any one after that. You could find the maximum, right? Say it's right there, and then you could also find the y-intercept. This would be an easy one because I know it's at 2, right? Because I know that's where it crosses. So then you can come down here and make it at 2, and then that should be good, right? And just double check that your x-intercept's in the right place. But you could use either one to make that graph. But yeah, that's how that works. And the same thing, right? It's questions just like the ones we did in class there.